Okay, so good morning, everyone. I hope my voice is loud and clear. I hope my voice is loud and clear. Good morning, everyone. I'm asking my voice is loud and clear. So last class we have realized that the strain energy cannot be treated with superposition theorem because of the cause. Sorry, the cause, which is this load, and the effect, they are not having a linear relationship. Okay, so as for now, any doubt you can ask me, otherwise I'll proceed further. All right, so I'll start now. So yesterday class we have seen strain energy due to axial loading, right? Now, what will be the strain energy if we have, let's say, shear? So the topic of discussion will be strain energy stored due to shear force applied. Okay. So let's take a case over here. Acha, remember that due to axial loading it was integration of sigma epsilon upon 2 into dV. Okay. So if we do a just a analogy, U shear will be sigma की जगह tau आ जाएगा, shear नॉर्मल स्ट्रेन की जगह shear स्ट्रेन आ जाएगी, 2 की जगह 2 रहेगा, dV की जगह dV आ जाएगा, like that. So this is way how you can look for strain energy. Due to shear forces. We can derive it also, not a big thing. Let's take a element, or let's take a body. Let us say that this is a dx dy x y इसे y मान and dz. Okay. Now let's say we have applied a load over here, some load P, और इसको 2D में अगर आप देखोगे, so what you will observe that there has been some deformation. So we'll get a work equal to force P, sorry, force P into this D. Actually, this is going to be a differential work because this D can be written as gamma into dy, और work can be written as P की जगह आप लिख सकते हो tau into area. Area will be this guy. So this is dx dz dy into gamma. And one mistake we have done, the load is gradual, so we'll use half. Okay, this is for gradual loading, as we have seen earlier. So obviously a 1/2 term will be there. And after that, W by V is equal to, और इसको ऐसे भी लिख सकते हो आप, W या strain energy equal to half tau gamma into d. So just another way of writing it. But how to remember it, I have already told you, because we are in competitive exam preparation right now. So this is how you can remember it, right? Okay. So this was strain energy due to shear forces. Actually, what I am doing is I am calculating strain energy for all the internal forces. तो नॉर्मल फोर्सेस के लिए हमने कर लिया है, shear forces के लिए हमने कर लिया है, बेंडिंग बचा हुआ है ना, बेंडिंग मोमेंट, whenever there will be a bending moment there will be normal stresses only, so I'll be using the same formula for normal stresses. And shear के कारण जो बीम में shearing और बेंडिंग होती है, now we'll calculate for those cases. चलिए करते हैं. So third part of the discussion will be strain energy due to bending. अब एक बात बताइए यहाँ पर कि we know that the formula is sigma epsilon upon E into dV, right? और stress upon strain is equals to E. We can write like that, no problem. So epsilon can be written as sigma upon E. This is for linearly elastic material, right? Linearly elastic material. And now what we are going to do is Substitute epsilon, so sigma square upon 2e dv, like that. Okay. Now we know that sigma is equals to my upon I, because we want to calculate for bending moment. So the normal stresses that were generated due to bending moment are given by this relation. So let's substitute it over here. You'll get u equal to m square, which can be a function of x, y square upon 2e I square. dv can be written as dA into dx. So this y square dA, we all know that it's the first moment of area, second moment of area. We'll go off with this. So what you have to remember is u equal to m square dx upon 2ei. This is one of the most important formula you have to remember. Okay? Next would be rarely used. ठीक है, बट यहाँ से अगर क्वेश्चन आया तो ये बहुत सारे बच्चे स्किप करते हैं. It could be a rank deciding question for you. Okay? I'll explain. So we have heard about transverse shear. And we know it is equal to beam की बात कर रहा हूँ मैं, ठीक है, bending. And we know that tau equal to BQ upon IB. I hope you remember this formula. So we know this guy. We take him. And this is going to be dx dA dx you can write. And again tau by gamma equal to g, so you can write tau equal to gamma equal to tau by g. So we'll have u equal to integration of tau equal gamma equal to tau by z, so tau t square upon 2, like that. Just a minute. क्या शेड्यूल के अकॉर्डिंगली आपकी क्लास था ना? दैट इज व्हाट आई हैव सेंट यू, राइट? आपको शेड्यूल मैंने यही भेजा था ना? आई चेक्ड इट वंस. टुडे इज फ्राइडे. यस. क्यों नहीं था? आज लेक्चर क्यों नहीं था? I've check your WhatsApp Friday, Saturday, Sunday, 8 a.m. to the third year has students at lecture at 9 a.m. Friday. यार दिन भर इतने लेक्चर हो गए हैं भाई कि पता ही नहीं चलता है कब क्या चल रहा है जब लिखा हुआ है सब. चलो ठीक है. यार पहले बता देते मुझे, किसी और इंस्टीट्यूट में लेक्चर था मेरा आज।